This is pragdave session. Please wait a while until we will start. This is pragdave session. Please wait a while until we will start.
端っこしか出てないからこっちで直す。はい。おお、これいいですね。ありがとうございます。傾き的に。
This is session pragdave session. Please wait a while until we start.
これでいい？多分これでいい。
あ、オッケーオッケーオッケー。はいはい。オッケー。
あと音は。
なんか喋って。
適当に喋って普通に注意を受けます。
私後ろの方で楽しいわよ。
ありがとうございます。Please wait a while until it starts.
すいません。
もう日数使ってるんで。
申し訳ない。
あ、入った入った。
悪いけど水もらってもいいかな。水がいいです。はい。
リレーしてたから聞こえへんので。
お。I need water.
Because you got lunch, you see, you got fed. I did not. Yeah, well, you're more important.
This is pragdave session.
ありがとうございます。
You need some drink? Okay, thank you.
This is pragdave session. Please wait a while until it starts. This is pragdave session. Please wait a while until it starts.
Why are we sitting so far apart? In the old days, it's because we'd have swords.
Yeah, probably. This screen is so important.
It is very important. Yeah.
Ladies and gentlemen, thank you for coming to the Rakuten Technology Conference 2013. The next session titled Meet with Legendary Geeks by computer programmer, author, and editor Mr. David Thomas and the fellow of Rakuten Institute of Technology, Mr. Yukihiro Matsumoto, will start at 2 p.m. Please wait for a while until it starts.
But he'll still be a fellow tomorrow. Do you want to start?
Forget it.
It's not raining.
Yeah,
Ladies
probably
and
the
gentlemen,
typhoon is
thank you for
gone.
coming to the Rakuten
Getting far
Technology
away.
Conference 2013. The next session titled Meet with Legendary Geeks by computer programmer, author, and editor Mr. Dave Thomas and the fellow of Rakuten Institute of Technology, Mr. Yukihiro Matsumoto, will start at 2 p.m. Please wait for a while until it starts. Ladies and gentlemen, the next session will start as soon. Please return to your seat. Ladies and gentlemen, thank you for coming to the Rakuten Technology Conference 2013. Now we'll go to the next session, Meet with Legendary Geeks, pragdave and Matz. Please welcome Mr. Dave Thomas and Mr. Yukihiro Matsumoto.
I don't think I'm not deserve to be called as a
legendary geek.
Well, you're more of a geek than I am, so.
Anyway, I am a creator of the Ruby language, and he just presented about the language named Elixir, which is the distributed functional programming language. So if there's no objection, if you have objection, raise your hand. So we are going to start with some kind of the object-oriented programming versus functional programming for today or something like that. So how Dave, how do you think about okay, you wrote the book about the Ruby, the programming Ruby book, and the Peacock books. Then you wrote the Elixir book, which is the distributed functional programming language based on OOM. So, what do you think about the, say, comparison?
That's really interesting because clearly Elixir is based on Ruby, the syntax. And it has a very Ruby-like feel to it. But the big difference is that it sits on top of the Erlang virtual machine, and it's designed to run programs that are many, many processes, and that are programmed in a kind of functional style. And I gotta say that when I first came across it, I was very nervous about this idea of writing functional code. I've been writing OO code since, I don't know, I guess my first OO program I wrote in 1974 with Simula. And I've been writing OO ever since. And to me, that was the way you wrote code. I mean, there's no question that every time you wrote a program, it was supposed to be an object-oriented program. And one of the cool things about Ruby is that it wasn't as religious about enforcing an OO structure. You could actually do it in many different ways and still get the benefits. But I think there are a couple of issues or problems that we have to look at when it comes to OO programming. Clearly concurrency is one of them. Managing state is very difficult if you're writing a concurrent OO program. And there are many ways of trying to get around that, but none of them are particularly easy to do. But I think there's more than that too, and it comes back to what you said in your keynote, and that is we don't really know what we're doing. And OO programs are designed to model the world. I mean, the origin of object orientation was simulation systems. And in fact, the reason for object orientation was because it was very hard to write simulation systems in the languages like ALGOL and Fortran. And those simulation systems say, I am going to create a world which is a model of the real world inside my computer, which kind of implies that you know what the real world is. And as you said, we don't know what the real world is. The other problem I have with OO is not to do with OO itself, it's to do with the way people use it. And that is, they think the most important facility in object orientation is inheritance. And so they will design these big programs which have these big trees of objects where they're using inheritance to structure their code incorrectly. Because the real world, the world that you can touch, really does not have that much inheritance in it. In the real world, we use things, we put things together, we compose things. But we don't say that this is a kind of that, but has these differences. We just like use things around it. So OO did have some problems. Not enough to make me leave it, but enough. So then when I start coding in a functional way, I discover that I can actually write code that does exactly what I want without having to worry about state, about objects and their data. I can instead write code that thinks about how you transform that data. So you start off with whatever your input is, and it goes through a series of steps, of transformations, until you get your output. And when you think of coding that way, it's simpler in many ways. When you're doing OO development, I'm having to think about objects and classes. I'm having to think about invariance. I'm having to think about sort of who's got this information when I need it, and do I have references? When I'm doing it in a functional way, I don't have to think about that. I can just think about a linear progression of code. So that's one of the reasons. The other reason is to do with the fact that I have multiple processes, but I've already talked for far too long.
So the key point is the definition of functional programming. This is quite difficult to define functional, just because in old days, decades ago, so 10 years, 20 years, 30 years ago, the Lisp was considered as a functional programming language, just because the most of the Ruby, the Lisp program conform the way the function calls. But these days, virtually no one calls Lisp as a functional programming language. So the definition of the functional programming is varies the age to age. So
well, I would point out that 20 years ago, people called C++ an object-oriented programming language.
Yeah, probably. Yeah, the definition of object-oriented itself is pretty vague still. But these days, the key feature of the functional programming is the being declarative. So the functional programming, the current functional programming, especially influenced by the language like the Haskell and the OCaml, is pretty influenced by the mathematics, and mathematics is basically a way to form a relationship, provide a formal way to describe the relationship, or in a kind of a descriptive way. So I think that's the very important point. And then as a side effect, we introduced some kind of immutable data, which is not the declarative data structure will not change anymore. So that's like the real function does the same result from same input or something like that. So they are very important to be descriptive. So that's the current day functional, the basic of the functional programming. And but still, Haskell or Camel and Erlang is all of them are called functional programming language, and the fundamental is pretty much different from language to language. So what do you think about the definition of functional programming and the difference of these different functional programming languages?
I honestly don't think it matters. I think that it's a convenient label to put on things in the same way that OO is a convenient label to put on things. But Haskell is very different to Erlang. And partly that's to do with the way people use it. Haskell is used as a language to explore as much as anything else. It has a very academic feel to it. And as a result, I think it has not got the use that it deserves. People look at it and, chapter 1, monads, and everybody goes, oh no, and they move away. So I think that that what counts as a functional language, I don't think really matters as much as the intent behind it. What does it let you do? And I think if you look at what it lets you do, then you can form some definitions. So, for example, an OO language allows you to create factories that will instantiate objects. Those objects will have behavior, they'll have state. In the same way, you could say a functional language allows you to apply functions to data and to transform that data. But beyond that, I don't think you really need to worry too much about is Elixir a functional language in the same way that Haskell is or something like that? No, it's not. But the same way Ruby's not an OO language in the same way that Java is. So I think it's really just a question of fundamentally, does it get the job done? And as developers, I think that's our main concern. Do we enjoy and are we productive with our tools getting the job done? And I don't worry so much about definitions as that.
So let me focus on the Elixir. So the Elixir is the syntax-wise pretty much like Ruby, and the semantics-wise it's basically alone. So what's the key point of the Elixir? Except for the syntax.
From the syntax point of view?
No,
not from
the semantics point of view.
So if you write, okay, so first of all, Elixir, I think the main selling point of Elixir is not the language. The main selling point of Elixir is that it runs on the Erlang virtual machine, Beam. And Beam is as old as Ruby, I guess, close to.
Older.
Older, okay.
It was started in 80s something, 87.
Oh yeah, you're right. Yeah, you're right. Okay, so it's an old technology. It's a proven technology, and it allows you to write very, very distributed, multi-process, reliable computer programs. The Erlang group claimed 9 nines reliability, whatever that means. But there are telephone exchanges out there running Erlang that have never stopped running. They have never crashed. And they have been updated all the time with new code injected into running applications, which is really quite stunning. So Elixir runs on that. I think that, to me, is the main selling point. But then the question is, why Elixir and not just Erlang? And the reason is that I think Erlang, the roots of Erlang were languages like Prolog. And it is fun in a kind of masochistic way. And it can be a bit ugly. The people that brought you Erlang were not particularly concerned about making it fun for programmers. They wanted to make a language, their focus was on making a reliable language, and they did that very well. Now we have the luxury of their work, like you said, standing on the shoulders of giants, and now we can say, okay, given this VM, given this framework, what can we do to make it more fun for developers too, or more productive for developers? And I think that's what Elixir does. It takes the best of two worlds. Does that make sense?
Yeah, I understand. So do you think the Elixir or the Beam is the future of the development?
Do I think Beam is the future of development? No. But I don't think anything is the future of development. I think all we ever do is take small steps. And I think that there is an argument to say that something like Beam is the next small step we have to take. Because, as I said, the world is becoming distributed, and more we're writing programs that run on multiple processors and in multiple locations. I mean, everybody who's written a front-end bit of JavaScript that talks to a back-end JSON server is doing distributed programming, and you know the pain of doing that. So if you can produce an environment that makes it easier to do that, and that makes it more reliable to do that, that strikes me as a good idea. Beam is one such thing. What I'm hoping is that as time goes on, more people will invest time in producing similar, basically network operating systems that will support the kind of code that we need to write for the next 20 years.
So the working on the Elixir, so the two main concerns of mine are, these days the systems are the more and more polyglot, so the multilingual systems are pretty much common, but it's quite difficult to work with the other programming language to all one system. So yeah, you can write some kind of C extension to Beam, but it's not really that kind of easy task. So, and then even the all-on system is pretty distributed, so that it can communicate with the process or the programs written in the other programming language. So that's my first concern.
And I agree. And I am someone who really does not like the idea of a monoculture, a world in which we all do it the same way, using the same tools and the same languages. I don't think that you will necessarily want to write your entire application code in Elixir. But I think what Elixir and Erlang give you is the ability to write the underlying infrastructure for that code. So the sweet spot might well be JavaScript in the browser, Elixir as a distribution mechanism, and Ruby as some of the back-end server code. And you can plumb that together very successfully. If you use, I don't know, a messaging system right now, the chances are you're writing, you're actually using some Erlang code, right? But you don't have to interface to it directly at the source level. You're sending it messages and it deals with it. And we can do the same kind of thing as we grow.
Mm-hmm. So how do you communicate to the Ruby system in the middle and the backend system and really the beam?
Well, I would suggest we could use REST.
Mm-hmm.
We could use sockets. I mean, whatever works. I mean, that's one of those questions that depends on the architecture and what you're trying to do. But I mean, there are many ways of doing that. And I think if you think about it in terms of the future, the idea that we have multiple cores, multiple processors, means that it's a really good idea not to tightly couple the Ruby and the Erlang and the JavaScript and everything else, right? We want to have message passing between them because that's the only way we can be parallel. So I don't worry very much that Erlang does not have a binary level interface to Ruby, because I think the fewer binary level interfaces we have, the better our code is.
So, yeah.
I mean, do you have the same issue with Ruby, do you think? I mean, because Ruby, you can write C extensions, but you can't particularly, interface it to, say, you couldn't have a code that interfaces to both. Well, you can, but it's harder. C and Java and whatever else. I mean, how do you think Ruby is a better solution for the polyglot framework?
I'm not sure. The most polyglot system consists by some kind of API access via REST or something, or JSON RCP or something like that. So I think that's the way. So but still we have to work on some kind of efficiency of the communication between the system within the different programming languages.
See, when I first started, when I was a lad, all protocols were binary because it was the most efficient way of getting things done.
Yep.
And quite often, it wasn't even byte-oriented binary, it was bit-oriented binary, because that way you could get the most data down a low-speed communications line. And we used to spend, days writing code that would shift bits and mask bits to get the right data out of the data streams, right? And if back then someone had said to me, "Oh, you'll be writing all your data communication protocols using English readable or human readable strings," and yes, you'll be passing integers as characters that you have to convert from binary into a string, and then at the other end you have to convert it from the string back to binary, and you'd look at them like they're an idiot. Because, first of all, think of all that bandwidth you're wasting, and secondly, think of all the CPU time you're wasting converting integers to strings and back again, right? Clearly, that would be an insane thing to do. And yet nowadays, that's exactly how all of our programs talk to each other. We use REST, we use JSON, we use JSON, we use XML, we use whatever else. That's the way it is. I think the same kind of thinking applies to the higher level, how are we going to link these things together, right? Yes, maybe now it's not as efficient to think about a decoupled way of linking them. But 5 years from now, when our processes have tripled in speed, who cares?
Yeah, I agree. Yeah, 30 years ago, if I present a system to access to the servers in the States from Japan, every time we get the information, so it was quite a crazy idea.
Right. I mean, really, 10 years ago, if someone had said, "I'm going to run a large corporation using this scripting language called Ruby," people say, "But it's not efficient. I want to write it in C or C++ or Java." Even Java was viewed as being not efficient.
Yeah, 10 years ago.
So times change, and I think one of the things as developers that we have to do is to realize that right now everybody in this room is obsolete. Right? You are all behind the times. Because since we started, the world has changed. And it's always going to change. So we have to be always thinking a bit like, entrepreneurs. We have to be thinking, what's it going to be like a year from now, 5 years from now? And just because it's our lives and it's the way we pay for our food, we need to be getting ourselves in a position where we will be ready for that new world. You know? Don't wait for the world to make you obsolete, but you've always got to be thinking, what will be possible? What's the way it will work? And start researching and start learning those things so that when it does happen, you'll be ready. Like you said, you got to run twice as fast as you can.
Yeah. Yeah, if you stay, yeah, if you don't move, you swept away in the past.
Right. I mean, the word for that is maintenance program.
So, yeah.
So the other thing is, this is a nice forum, and I would be very interested, not necessarily now, but if anybody has questions or topics that you would like us to discuss, then that would be an interesting idea. Just, you know, raise a hand and shout it out.
Yeah, I think we had discussed about the functional programming and object-oriented programming enough. So if you have any questions and the topic to discuss, so raise your hand and come before me. And then, anyone? Very quiet audience.
May I ask you a question?
Yes, me?
Yes, you.
Oh, yeah.
All right. And this is probably going to be very rude, so I apologize. All right.
Okay. I was done.
And maybe I'm going to ask the audience a question too. Do you feel that you are a typical Japanese developer?
I'm not. So I'm not the typical Japanese developer in several ways. And the first way is I'm not. I have never been write a program for clients for 20-something years. So my first assigned job was to create the software tools for our engineers. So we can define our spec, our requirement, our spec, and we can design our tools for ourselves. So it's not for the end user clients. And then my second project is the Ruby itself. So it is open source software. So I designed by myself. And then my second the assigned project was some kind of experimental database program for the shipbuilding database. It's kind of research project. So there's not any user clients. So. And then after that, I moved to my company in Shimane. So I spend most of my time working on Ruby. So 24 years, I have never worked for the end user client.
But is that the cause or is that the effect? Did you spend that time working on things that interested you and working outside the regular commercial world because that's what you fell into? Or is it the other way around? Did you have a personality that made you have to do that?
Yeah, I don't know. Yeah, from the manager point of view, I'm not very capable, the manageable person.
Right.
So I'm quite rebellious, and I claim something very directly. So I was being easy to say no to my boss. So that's maybe one of the reasons I was assigned these kind of tasks. Maybe
to keep you out of the way.
Yeah.
So I mean, to everybody else, is Matz-san then some kind of prototype that is interesting to emulate, or is it not thinkable that you'd say no to your boss and go and do something interesting?
Wait, yeah, come in here and take the mic. There is? Okay.
Well, this is just my opinion, but I think, well, the reason there are so many people here is because he's someone that everyone wants to emulate.
Well, I think you could do a lot worse than emulating.
Yeah, that's bad for managers. But you know, I believe the most Japanese engineers are too obedient, too easy to follow the orders. So no, it's just a company. It's just this is the work to make money, make a living. So you know, just say no. Yeah. If you don't like it, if you are not respected, so you just need to say no. Even in the big company.
I think you're right. I was talking to somebody yesterday about a system where they had a lot of tests, many thousands of tests, and they were all fine until a rush project came along and they had to make some change. And they changed the way one of the APIs worked. And now 1,600 tests fail. And every time somebody checks something into version control, they get an email. Everybody in the team gets an email saying 1,600 tests fail, and they all ignore it. And so, as a result, if someone actually adds a bug and 1,601 tests fail, nobody knows. So I said to him, well, okay, my suggestion would be comment out every single failing test. I said, because the reality is your software is running, you've deployed it already, it's being used in the field, so the tests are clearly out of date. Now, you could go through and fix them, but that would take forever. So just comment them out, and now you're back to having all of your tests minus 1,600, but they all run, and now if you have that one extra bug, you'll get an email telling you you've got the one extra bug. And he said, well, I've only just joined the company a year ago, and I don't think that I'm senior enough to be able to suggest that, right? So here, that's what I'm saying. I agree with you 100%, that in that kind of situation, I almost feel it's your duty to say, do this, because otherwise I am not serving anybody by doing that. So yeah, I'm going with your say no business, right? I mean, yeah. Ultimately, everybody has responsibility.
Yeah, yeah. But probably I should make a T-shirt say no or something like that.
Yeah. Well, you can always say Matsumoto told me to say no.
Yeah. Yeah. Use my word, my name. Matz told me that.
Yeah. Yeah. If you got a problem with it, go see Matz.
Okay, I would say no. So, any other questions from audience? Yes. Yeah, come here to the mic.
I'm wondering if you're thinking about new
Yeah,
language.
get the mic. Get the mic.
The mic fairy is coming.
I was wondering if you're thinking about creating a new language, because most of the languages come and go. I was wondering if you're thinking something different, something next to Ruby.
Yeah, I still being a language geek, and I love to learn about the new programming language. So recently I studied about the Clojure, STM especially, and Elixir, and TypeScript with the JavaScript world. And yeah, I have a lot of language, but I'm still a lot of things to work in Ruby field. So I created Ruby, so I refine, and I added new things to the recent Ruby. So we are going to release a Ruby 2.1 this year, and we are going to have the Ruby 2.2 next year or something like that. So I have still a lot of things to work in the Ruby world. So I'm not going to work new programming language. So but I still encourage them, encourage people to work on new language with new ideas. Like, the TypeScript is great, Elixir is great, so I encourage them. Even I encourage Rubinius X, which is the kind of new dialect of the Ruby language or something like that. So I'm not sure they will survive for years or something like that. But at least I will encourage and try.
I think there's just from the outside looking in, language design is an art, not a science. And everybody who programs as an engineer says, you know, oh, I could do that better. But the reality is, it's not just a question of doing one thing better. It's doing the whole language in such a way that the parts work together. And one of the genius things behind Ruby is that it has all of these different paradigms drawn from so many different languages, and they do all work harmoniously together, which is amazing. But I got a question related to that. If you could get into a time machine and go back to you in 1993, what would you say about the design of Ruby that you would change?
First of all, remove the Pearl dollar something syntax. Your language will surplus the Pearl. You don't have to worry too much about the Pearl. That's what I would advise to the Ruby designer 20 years ago. And maybe the other things I would say would be, well, so back then we had one CPU per computer. So, so a few years later, so the multi-core, the very distributed system is pretty much common. So the better design your language in the multi-language and implementation, and the multi-core, the many-core distributed systems in mind. That's what would advise.
And how would that change the language?
I don't know. Maybe we remove the threads, and then we have that kind of some higher level of abstraction of the component.
Cool.
I want to know, how do you react to the word TDD, or test-driven development? I'm asking this because it's not. I think it's an ideal way for teams to do TDD as a discipline, but for very high productive programmers, it can slow their programming speed, or they have another ideal way. So how do super geeks, legendary geeks, react to the word TDD, or strong unit test coverage?
I have a rant about this, so you better go first.
So some kind of test. So as we told you, so we have to run as fast as we can, but it's kind of like dangerous to make change. It's kind of risky to make change. It's kind of risky to progress. It's kind of risky to try new things. The test is kind of like a seatbelt, a safety belt for trying new things. So you can ensure you don't break the existing things. So you can distinguish the change from the bug you accidentally introduce. So in that sense, the test is kind of like a harness or the safety belt of to progress. So without that kind of safety belt, it's quite difficult to make drastic change to your system. So go ahead, you want.
Okay, I think I'm going to start by saying that there is no single truth apart from this one, because otherwise it would be contradictory. So the fact that test-driven development has worked for many people in the past and continues to work for them now does not necessarily mean it is the only way to write code, right? It's a tool, just like every other tool that we use. So it's contextual. You have to say, why am I doing this? Not, I have to do this because Ron Jeffries told me to, or something, right? There's a reason I'm doing this. It's just as there's a reason I'm doing everything else I'm doing. And part of our jobs is constantly to be looking at ourselves, saying, why am I doing this? Is it working for me? Or am I just doing this because I did it yesterday and the day before and the day before? And I think TDD falls into that camp. It's very interesting that there are really kind of two communities in Ruby when it comes to TDD. First of all, Ruby as a language has, I think, probably the strongest culture of testing of any language out there, and that's commendable. But they also have a large number of people who are almost religious in the way that they push testing on over miles. You know, if there's no tests, I'm not going to look at your code. Well, you know, I don't care. It's up to you if you want to look at my code. But they do things like that, which to me, every time I hear that, it means that I'm looking at a religion. I'm not looking at an engineering practice. And that makes me worried. Personally, and this is the first time I've said this in public, so I'm going to get in trouble now. Personally, when I am writing code for myself, I don't write tests. Let me tell you why. I used to write tests. I used to write a lot of tests. I used to be the person that I tell everybody else to be. And the fact that I used to write a lot of tests changed the way I wrote code. It made me think about how to structure my code so I could write tests. It made me be more accurate when I coded. It basically gave me a whole lot of good habits, a lot of good reflexes. And then I noticed that if I didn't write tests, I still wrote the code as if I did write the tests, right? I still had the good practices, but I didn't need to write the tests. And I actually kept some stats. I discovered that my bug rates were no higher. Right? I didn't actually need those tests to keep me bug free. In fact, quite often, the tests got in the way of me changing the code, because every time I made a change, then I had to go back and fix 15 tests. So personally, if I'm writing code for myself, I won't test it. I don't bother. If I'm writing code on a team of people, though, I will always write tests. Right? So that's an example of where I think the truth is contextual. Right? So you have to decide for yourself, is this practice helping me or getting in my way? And you have to be honest. It's not just, do I like doing this? But it's genuinely, is this helping? And I would always use that to make every decision, from, you know, what language am I going to use, what methodologies am I going to use, how big a team am I going to have, all of these things. You have to just always ask, is it helping?
So as my keynote states mentioned, so the being spontaneous and then being away from the blind belief is kind of my theme as well. So I 100% agree with what they've told you right now.
But the other thing about that that's interesting is that if you are just starting in software, I'm reading a lot at the moment about how people get skilled at something. It's not as easy as you'd think. The best theories that people have now is that the only way to learn things at a real true level is through experience. Right? You have to get out there and write the code or do whatever it is you do in order to get good at something. There's no alternative. And so with the testing question, I have to be very careful what I say, because if I'm talking to a group of people that includes people who are just starting in software, then really you have to test. You have no option, because what you're doing is you're giving yourself the experience of what it feels like. You're giving yourself the experience of designing code that can be tested, etc., etc. You have to do it. So the fact that when you're experienced, you may not have to, doesn't mean that you don't have to when you're starting out. An example of that, airline pilots. Most airline pilots have something like 10,000 hours, which is the number you use when people say you need 10,000 hours to become an expert at something. Well, actually, you need more than that for airline pilots. So they took some cockpit video of airline pilots, very senior airline pilots, training more junior airline pilots. And when they were training the junior pilots, and these junior pilots had 5,000 to 10,000 hours of flying time, when they were training the junior pilots, everything was by the book. They followed every single rule, right? All the checklists were followed, every single step was exactly the way it should be. What they didn't tell the pilots was they left the camera running on the next flight. And on the next flight, it was 2 experienced pilots. These were the same people that had been training the junior pilots. Well, the experienced pilots did not follow the book. They had more experience. These were the people that wrote the book. They don't need the book. And it turns out that they were actually more effective as pilots. They used less fuel, and they were judged to be safer, but they weren't following the book. Now, would those experienced pilots tell a beginner, oh, don't worry about the book? No, of course not. You need that 20,000 hours. But at that point, then really you set your own agenda, because you are genuinely an expert, and you get to decide.
So it's about time to finish. So you guys have one last question if you have.
And
Raise your hand quickly.
Make it a good one.
Okay, there he is. Good one.
Thank you. As I said just now, I come from China. Nice to meet you today. I want to ask.
I'm going to China tonight, so.
Thank you very much. Thank you very much. I want to ask Mr. Matsumoto a question. Ruby is beautiful, but many start-up companies, it's hard to choose which language they should to use, such as Ruby, Python, Node.js. And now Twitter and Groupon have changed their language to others. Can you give them some good ideas, such as Ruby is better than others? Thank you.
So these companies moved away from Ruby. So what do I feel or something like that? So that's okay. So the different company has different constraints. So the Ruby no longer will fit the constraints. So they move to the other things like Groupon to Node.js and Twitter to Scalar or something like that. So that's okay. But mention that if you don't have Ruby, it's quite difficult to these companies to form their service at the first hand. So the Ruby was pretty good at prototyping their services. But then if they wanted to, if they reacted the new system, so I think they can do that similar things in Ruby, and then they would do the pretty excellent work even in Ruby. But the company and the community should keep running. So they choose the different, newer, fancier programming language. So that's okay for me.
May I ask, how big do you want your company to be?
Sorry, I just wanted to ask this question. Now I work
Yeah, he's working for this company.
Yes.
So it's quite big.
So
Right.
I just wanted to hear about that.
Okay, so if I am starting a company and I choose, say, Ruby, and then when I get to $1 billion of turnover, I have to change to Scala. Well, that's a good problem to have, right? I don't care. And as Matz said, Ruby let them get to there, but they had an environment where they could very quickly try things, to modify the code, to try new technologies, to try new user interfaces, whatever it might be. They had an environment which let them rock and roll, right? After a while, they changed from being a startup to being a big company, and their needs are different. Their constraints are different. They may be looking at server costs or whatever it might be, deciding that the memory that Ruby takes is more than the memory that Scala would take, whatever it might be. So they make decisions. But I don't think you sit, like Matt said, you cannot predict the future. So you don't sit there and choose a language based on what would Twitter do, right? Instead you say, what do I need now? And then if I need to change 2 years from now, okay, I'll change. But I'll do that for a good reason. So I would strongly commend Ruby to just about any startup as a potential language.
Okay, thank you for a great discussion.
Yeah, thank you, audience.
Mr.
Yes,
Thomas
thank
and
you.
Mr. Kikuo Matsumoto. short 15-minute break. From 3 p.m., we will start the next session titled Solve Your Problem, Speed Up Your Life, and Panic Black Movie. The talk will be given by